Welcome to Haxby Shed. Today I'm going to fit an emergency stop button to this Nutool pillar drill press. I had a problem recently which scared me a bit and I need that emergency stop. What happened was I'd improved the wiring in here, but I'd disturbed this switch. Now this switch is made of individual components, so two switches and a relay. You can take the back off it to get inside, and two of the contacts on the coil touch together, and so I was running this, press stop, it stopped. Leave it, it would start again, all on its own. And I thought, gosh, got to do something about that. I solved the problem. The problem was to do with the way it was put together. But anyway, I've been looking out for an emergency stop button at some sort of sensible price. Because if you go for something like Schneider, it's like £35, which is ridiculous. Sorry, Schneider. You know, I think I found something. I'll show you. Just before I show you the new ones that I bought for the pillar drill press, I'll just remind you of this one. Now, when I was putting the wall-mounted inverter up, I bought this for about £7, I think. It's cheapo plastic, you know, brittle plastic. There's chrome on this knob here, but honestly the chrome isn't chrome, it's just plastic. And I reckon that was about, you know, the most basic I could get away with. I've always intended to replace that at some point, or at least the push switch. Now these emergency stop buttons were from a gas system supplier. If I went to any kind of electrical wholesaler, or even Screwfix, if you're in the UK, you'll know that, you know, the emergency stop buttons started at probably £15 to £20, and I still think that's a ridiculous price. But if you go to some kind of, you know, supplier, wholesaler for gas instruments, so where you've got an emergency stop button which shuts down a gas valve of some kind, they're much more sensibly priced. And I bought these from Under Control Instruments Limited, but they weren't the only supplier. I bought direct, not eBay in this case. So this here, push button unit with two normally closed, rated at 10 amps for resistive loads, that was £4.50. Now, if you want that in euros or US dollars, add about 20% to that. Okay, and then I also bought, because I couldn't resist it, I only wanted one, but I couldn't resist it having found them, so I bought two. These complete units. Now this one is one normally closed, one normally open. You know, good quality plastic, good quality switch like this. If I could only make that work, that's it. Like that one, £9.50 delivered. I mean, how, you know, you can't beat that really. So, you know, check out the gas equipment suppliers. I think it was called a gas emergency stop, but honestly, it's just an emergency stop. So I'm going to use one of these. Now, before we go any further, let me say, I have some electrical knowledge, but I'm not an electrician. I'm only sharing, I'm not teaching. And if you get fried and go to heaven, don't send me a message about it, okay? Now, the emergency stop switch, the way I'm going to wire it, and this is just a sort of figurative diagram, it's not a wiring diagram. The way I'm going to wire it is, I'm going to use both gangs here, and both normally closed. One of them I'm going to put in line with the coil of the NVR switch, but the NVR switch could fault, and these contacts could weld together, so that basically the coil mechanism is inoperative, it's just welded completely shut. And the emergency stop switch would then have no effect. So I'm going to put the other gang in line with the motor. Now that brings us on to a discussion about switch ratings. Now an induction motor will draw maybe 5-6 times its normal running current at startup. And these switches in general I should say, are rated, but they're rated differently depending on whether or not it's a resistive load or an inductive load. So these are rated at 10 amps. It actually said on the website 15 amps for this, but it isn't, it's 10. But that's 10 amps resistive, and I think that's classed as AC1. From what I've read, I'm no expert like I told you. So this has an AC1 rating of 10 amps, which means it can make or break 10 amps resistive load. But for a motor, you'd want something, a switch, rated at AC3 for inductive loads. So the AC3 loading of this switch, you know, might be 2.5 amps if it was driving an induction motor, and for resistive loads it would be 10. But the thing is, the big current spike happens when you start the motor. Well, I'd never be starting the motor with this switch. So therefore I think it'll be fine, because the motor would always start on the relay. So I think, 10 amps will be okay to put that in line with the motor, given that it will never be starting the motor. And the normal running current of that motor is 6 amps. So it's a 1 kilowatt motor on a 250 volts single phase, and I measured the current and it was 6 amps. So I think that's going to be okay. Now, that's my intention, to use both these gangs. To some extent it depends on where I can put the wiring. So we'll have to see if I can make that work, but I'm sure I can. So the first thing I'm going to do is actually swap over this body and put it on here, because this is normally closed, normally open, and I want two normally closed. Look how easy this is. Press that down, comes off. It's on. Dead simple. Because I'm going to be putting this on its side, I've had to move this emergency stop disc around to turn it 90 degrees, and it's just held on with a bit of tape, but it's also held on with this, knob clamped up. It just stops it spinning, I suppose. And the tape looks like it's good enough still. Try and get it on something like straight. Now I can still see all the pulley settings on the speed plate here. Unfortunately it covers up the name, Nutool, Doncaster, but some sacrifices have to be made. I'd really like to have the wiring come through the back of this switch body, but it's not practical, the spindle's in the way. So I think I'll have to bring it round the side here and just make it as neat as I can. Anyway, the next job is to get this off, get the front pulley off, get inside and see what we're doing then, see where I can drill it to screw it on and all that. Right, that's the pulley broke free. Last time I did this it wasn't very tight at all, but I was a bit concerned if I over tightened this pulley here, I'd break the edges of this cast pulley. So I put a bit of load on it. I had to put a block under the spindle, because obviously as you tighten this it pushes the spindle down. So I put a block on the table below, and I just used a long screwdriver and just wedged it in there with a bit of load on this, and it just popped off. I must have cleaned the taper last time I put it back on, so it was a bit better fixed this time. I often play the radio in here, but each time I want to do a bit of video I have to turn the radio off, because if there's music on I get a copyright problem. So Andrew said to me, well, get an Alexa and then you can just say, Alexa mute, Alexa play. But unfortunately I'm still not got into that habit, and I keep calling it Amazon. So I'm going, Amazon, Amazon, play, play. Anyway, and then of course Alexa sulks when I do that. I've taken the intermediate jockey pulley out, it just pulls out like that. And there's 4 screws hold this. I'm not going to show you because I've showed you this before. Oh look, that's open at the back in there, I'd never realised that. I thought it was in a tube. I'll put a bit of grease on that before it goes back together, although it's not dry. Right, I've just about worked this out now. So the bearing casing comes down to about there. My emergency stop button comes down to about there and is about that wide. Now I think I can just put a couple of holes in here and get my cables through there and keep it concealed. It means I've got to drill through, Doncaster. I think it'll just have to be like that. That'll go there. I can probably drill a hole there and tap it. Just have to be a bit careful how I do that. I'll take this piece away here because it's kind of in the way, because I want my cables to go there and there. That's the plan. Well, here we go. This is where small job becomes big job, which is typical for this. I don't know if you saw the video where I put these brackets on. One job became 5 jobs. Well, I was looking for some cable for this switch and I found something. And I looked at it, it's 0.75mm square cable. So I thought, well, I'll check the rating. Well, that's only rated at 6 amps. And this motor, without any load, takes about 6.5 amps. All right, there's a safety margin, I know. But when the thing's starting up, it maybe takes 20, 25 amps instantaneously. And I know 6 amps is the continuous rating, and you can take a lot more than that for a short time. But I checked these cables here, and these are 0.75 as well. Well, I think they're too light. They always felt too small. They pulled in and out of these glands far too easily. So I've got some rubberized 1mm square cable which takes between 14 and 20 amps depending on the situation. And I nearly changed these last time when I did that last video. And now I'm going to have to change them. So small job becomes big job. I managed to drill that without hitting anything vital. That will be just fine. So I just need a drill for the screw holes into here now. I've drilled 2 holes 3mm and I've tapped them 4mm by 0.7. I did them 3mm because that's what I've got and it's near enough. I'm still trying to figure out this wiring. So I said that the cable that comes to this machine is 0.75mm squared, and I look it up and it's rated at 6 amps. Now that connects to another piece of wire, 18 American wire gauge. I looked that up, it's rated at 14 amps. But when I look at the equivalence, 18 AWG is 0.75mm squared. So it looks like if I label my wire American, I get 14 amps, and if I label it European, I get 6 amps. So what is it? Has the Europeans got more shares in copper mines or something? It's ridiculous. Maybe you can explain it to me, but that's what it looks like to me. So as this cable hasn't actually fried, and it's been there for 30 years, I'm going to stick with the 0.75mm because I just don't want all the work of changing it. But it kind of backs up my suspicion that, moan, that the cabling in, UK houses is so overrated. And now they kind of insist that you have 25mm square cable coming from your main fuse to your consumer unit, and yet the cable in the ground is only 16. I'll probably delete this bit of video, but it drives me nuts. Anyway, I think I'll leave it the same. Well, as this is a new bit of installation, I'll use 0.75mm for the coil from the NVR switch and 1.5 square mil in the motor circuit. And then when I know which way round I'm doing it, I'll put a brown sleeve on this or a blue one on this one, depending. Or I'll use some coloured tape if I haven't got sleeves big enough. Well, 24 hours further on, and I'm hoping to get this emergency stop finished this afternoon. But I just thought I'd show you a few things that have come through the post today. You know, probably, if you follow my channel, that I've got a Harrison universal milling machine that needs a new table nut. And I'm not quite sure whether I'm going to bore it, cut the threads internally with a bar, or whether I'm going to be making a tap. So I bought some acetal here, Delrin, 32mm diameter. That could be a practice piece if I decide to cut the thread with a boring bar. And then if I go the other way, if I make a tap, here's some 3/4 by 4" silver steel that I could use to make a tap, so that's 19mm by 100 if you prefer millimeters. And I've bought myself this 29-degree grinding up gauge for Acme. So I don't really know which way I'm going to go with that. I've bought a tool holder from China for the insert that would allow me to cut this tap. That might be 3 weeks before it arrives, but it was a good price. We'll get into all that some other time. Or I might, using this, grind up a piece of silver steel. And if I did, well, I could use it for external or internal. Okay, that's all in the future. It might be another month before I do it, but you can see these things can take a long time in the planning. Let's get on with this emergency stop, shall we? Let's get this out and see if we can get onto the back of the relay terminals and put this emergency stop in line. Some of these NVR switches have extra terminals that take an emergency stop. You know, you can see that option on them. And if you don't know, NVR means no voltage release. So what that means is you press green, a relay pulls in. If you get a power cut, the relay is dropped out and then it won't restart if the power comes back on. So obviously it's a safety feature. This one's quite old school, and we can take the plastic back off it when I get it out, obviously. And I think we can get to all the components individually. There we are. So this box comes off the back and the relay is just in here. I noticed that there's 2 reds and 2 blacks come out of this, so I don't know which one's live and which one's neutral, because obviously these wires a blue and brown, okay, so the harmonised wiring colours. We'll figure it out, won't we? You know, I'm feeling quite positive at the moment, not that you care, I suppose, but you probably know that I volunteer for the Institution of Engineering and Technology, so it was the IEE, and it's like the IEEE in America, and we've been making some really good connections. And you know, if you can inspire people into engineering of any sort, that's quite satisfying, I think. Right, you see the relay, and I've just dropped one of the screws. It's actually a double pole relay, this one. 2 sets of contacts, 1 coil. So around here, brown is live and blue is neutral. But as I said, I think before, there's 2 black wires in and 2 red wires out of this. And when I trace it through, what arrives from the socket as brown leaves from the switch as blue. So it's swapped over by the time it gets to the motor. Now, it might make damn all difference while everything's working fine, but if some poor person comes along to fault find it and gets to the motor and finds that live and neutral are swapped over, well, you know, who knows what would happen. So I need to put that right. Well, it turns out these are actually crimped. I thought that they were American type screw-on ones, but they ain't. So, you know, more of this small job becomes big job stuff. Well, in the finish I had so much to disconnect in here that I just decided to replace all the cables anyway with the thicker stuff, except within the switch itself, because that would involve soldering and, you know, that would make it a bigger job again. So that's what we're doing. Right, everything's wired up now, apart from the motor. So, turn this on at the wall, keep my fingers well out of it because everything's kind of exposed and live here. If I operate this switch, you should hear the relay click, 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 click. On, off, on, off, on. If I hit the emergency, you should hear it click off. Release it, doesn't reset the switch. On, off. So that's operating as it should. So now I just need to get the motor wired up. So this label is on the underside of the motor terminals cover, and this side is with overload protection and this side is without. So I'm guessing it's this side, I don't know, but anyway, my point is this, look. Your supply goes up at A1 and A2, but it says to reverse the rotation, interchange the leads from inside the motor to A1 and A2. So it's quite possible, because I've taken out that switch over that was on the back of the NVR switch. If I wire it the same colours here, the motor will probably go the wrong way around. Well, we'll figure that out. But it's quite possible that when they put all this together in the first place, the motor was the wrong way, so they just switched it over behind the NVR switch. I've no idea, actually. But the thing is, you see, if one of these was labelled blue cable for neutral, well, if I understand my electricity 101 properly, then the blue cable and the earth case should be at about the same voltage. But if it's coming in live on the blue, somebody could easily touch that, you know, give themselves a zap. So it's important to get it the right way around, even though the motor doesn't care which way around it is, other than its rotation. You still want live on brown. I don't know if you can make that out, but that's the terminal block on the underside of the motor, and they've put the blue onto the red. Now I always think of red as being live, so I would always put the brown onto the red and the blue onto the black. So maybe that tells me something anyway. So I'm going to wire it the other way around. I'll put the brown onto the red, and hopefully that'll be right. I've put crimped eyes on that motor cable. Well, the hunch paid off. If I put live onto the red, the motor goes the right way. So, switch it on, press button, motor will start. Everything will rattle. Stop, obviously. Start. Stop. Now, I found an unexpected advantage of having this second switch in here, because now look, with this pressed, the coil disconnected, if I press green, for the time I'm pressing green, the relay will engage. Do you hear it? But the motor won't start because the line to the motor is also disconnected with this switch. Now if Tony's watching, he'll know what I mean, because he showed me a lathe the other day which had a pull down guard, and if you lifted the guard, this happened. You could still do that and the lathe would start whilst ever the green was pressed. So it's a failure with that design, but happily overcome with this. Now if I let that out, probably... so probably it'll work like it's supposed to. So what's left to do? Well, get this back in, get some P-clips on these cables to make sure that the cables that go from here to here can't get caught up in this, even though it only goes up and down, of course, and then get the top back on, the pulleys back on, etc. I couldn't get the P-clips in because I can't get my hand into the top of the drill casing, so I've made this bracket, threaded it, 4mm. Hopefully that'll work. Well, even that involved a bit more work than I'd planned. I threaded the plate and I put a lock nut on it. Couldn't get my fingers in. Well, that's finished. Took me a lot longer than I thought it should, about 8 hours altogether. Lots of fiddly bits to do, but it works. Normal. Emergency. Doesn't restart. Great. Absolutely worth it, because when I had that fright with this switch, you know, I wouldn't like to think what could have happened. And so, yes, about the only thing left to do on this drill sometime when I feel like it is to replace this collar. It's plastic. It holds the top of the rack for lifting the table. Why they made it out of plastic, I just don't know. Sometime when I've got a bit of steel that's 110-ish millimeters across, I'll make another, but this whole head will have to come off to fit it. Anyway, I hope that was useful. Thanks for watching Haxby Shed. Well, just as we sign off on this, to say, I don't know if you watch Tom on Hilltop Machine Works. He runs a channel, about 3,500 subscribers. He's a machinist, I would say semi-commercial. His sticker's on the door back here, but amongst all the sort of machinist presenters in my circle, we all know him quite well. Well, unfortunately, he's had quite a bad fire. He was working on a car in his workshop. He's normally not working on cars, but he had one in there, and he was doing some work on the petrol tank, and he spilt a lot of fuel, gas as he would call it, because he's in Virginia, and the gas went all over him, but the vapour spread across the shop and was set alight. Woof, flames. He had to run outside quickly. Luckily, he was wearing flame-proof trousers and top, otherwise he might well have died. He still had significant burns, so his shop is really badly damaged. He's only had it about 18 months. So, you know, if you watch his channel, I just thought that I'd mention it. He has made a video about the fire. It's there if you want to see it. But anyway, as of now, my acetone, my brake cleaner, are all outside. I've polished up the fire extinguisher. It's so easy to do, and I've been, you know, using the blowtorch, heating metal, and sometimes I've thought, oh, hang on a minute, the brake cleaner was only about a metre away. Blimey. Well, you know, it can happen, so look out. Anyways, just a finish note in case you know Tom's channel. See you later.